Hi everyone, good evening. Can you guys hear me? I can't hear any of you saying good evening.
Good evening, ma'am.
Hi.
Good evening, ma'am.
Good evening. So I'm glad to see so many of you here. I would just like to start by saying welcome to the workshop on getting started with Gemini 2.0 with Python. This is, as you know, a part of the GDG on Campus Presents Solution Challenge powered by Hack to Skill. I'm Uzma and I'll be your host for today's session. We are super excited to have you here because the solution challenge has started. It's going on in full swing and we are seeing so many people so interested in it, and it's really nice to see. So before we begin, I would just like to request you all to please keep your mics on mute during the session. We'll be having a Q&A round at the end of the session, so all your queries will be answered there. To talk a little bit about the solution challenge as a whole, it is organized by GDG on Campus in collaboration with Hack to Skill for student developers like you across the country from various colleges. And it's a great opportunity for student developers to tackle real-world issues such as, problems in education, bridging gaps in healthcare, working towards sustainability, and so much more. And you can do all of that using Google Developer technologies. And participants like you can not just gain invaluable skills, but they can also contribute to making a huge positive impact in the society. Uh, as most of you know, here is the timeline of the hackathon, and we are currently in the registration phase, which will go until 6th March. So 6th March is the deadline for registrations. This phase also includes workshops such as this one. This is our second workshop. And these workshops are scheduled to make sure to help you upskill and shine bright in the hackathon. Once you're done registering, you'll have until March 28th to submit your projects, and then we'll evaluate your projects and announce the top 100 on 21st April. This will be followed by personalized mentorship sessions, and then you'll have to submit your final prototype by 25th of May. After evaluating those, we'll announce the top 10, and those teams will be invited to the grand finale, which will happen in July. That's about it for the timeline. Now, for the next slide, I want to ask you guys how many of you are excited for the offline boot camps? Can I see a raise of hand? Great. Amazing. All right. So, we are aware that a lot of you are interested and a lot of you have been sending in your queries about the boot camps. And we have a very important update for you. The offline boot camps are now open for all participants. You no longer have to submit your ideas and do all of that. If you're interested in attending the offline boot camps, then you simply have to register for the solution challenge and fill an RSVP form, which will be circulated in February. And that's it. You secure your spot in the offline boot camps. Now, these offline boot camps are in several cities, and these are your chance to, attend some exclusive workshops and network amongst yourself to just, have your fellow student developers around you and have fun the entire day while you attend all these workshops. So that was an important update that we had. Keep an eye on your inbox because we will be soon we'll be sharing an email with all the details about the offline boot camps. So we will take care of all your doubts regarding that. Now, most of you, I'm sure, know this already, but if you need any more motivation, then here it is. There's a cash pool prize of up to 8 lakh rupees with the winning solution taking 2 lakhs, followed by 1.5 lakh for the second runner-up and 1.25 lakhs for the second runner-up. We'll also have 2 special category winners who will win 75,000 INR each. Apart from these cash prizes, we of course have some great opportunities for the top teams. The top 100 teams will get certificates of achievement, and the top teams will also get a chance to attend the Google Career Fair. So that's really quite a lot to take away from this hackathon. So I encourage you all to give it your best. Now, moving on to the main workshop for today, I would like to introduce you to Nikhil Rana, a data and AI specialist at Google. He has taken out the time to be here and share his knowledge with us. So I want to thank you, Nikhil, and over to you. Welcome to the session.
Sure. Thanks, Sonza, for the introduction. Am I audible?
Yes,
sir.
you're audible.
Sure. And are you able to see me as well?
Yes, we are.
The video is important because there is a demo which probably I'll be using the video, so that's why I just wanted to make sure. Let me start off by sharing my screen. Let me know if you can see my screen.
Yeah, we can see it.
Yes, sir, it is visible.
Okay, cool. So, good evening, everyone. I'm Nikhil, and I work with Google Cloud. So I'm here to sort of talk about and sort of give some sort of code demos also on Gemini 2.0. Before we start off, just using your emojis or any comments, like how many of you used Gemini before the previous versions? Cool, awesome. Okay. Good. So I think I'll get started. So this is the natural progression from Gemini 1.5 to Gemini 2.0. And a lot of exciting things are there as part of Gemini 2.0. And one specific thing that I'm most excited about which probably I'll talk about in open showcase. So just before that, how many of you have seen this demo? Like, just, I mean, with the reactions also is fine. Okay, cool. So for others who don't know about this demo, this demo is called Project Astra. This was showcased in last year's event that happened in May, and it sort of showcases the capability of the model to sort of interact with the environment using voice and video interactions. So you would have seen this in this demo, like the presenter is sort of asking certain questions, and the Gemini sort of checking through the video feed, what all elements are there in the surrounding, and accordingly answering the question. So this is something that was launched at that point in time, and now in December 2024 we have the experimental version of this model. So before that, if you are living under a rock and you don't know what Gemini is, it's the most capable model by Google, built by Google Research and Google DeepMind. And we've had previous versions of Gemini like 1.5, 1.0 Pro, 1.5 Flash, and 1.5 Pro. So we have now Gemini 2.0 Flash. Again, this is an experimental model that has been launched as part of Google AI Studio. How many here used Google AI Studio before? Cool, awesome. So yeah, it's available in Google AI Studio, as well as it's available on Vertex AI if you're using Google Cloud platform. Now, to talk about Gemini 2.0 Flash, what is new in this particular model? So just to highlight 4 major things. One is it has a better performance, that is both in terms of speed as well. So Gemini 2.0 Flash has almost 2x faster time to first token as compared to the predecessors. So time to first token is basically when you give a prompt, the first token that you see or the first word that you see that starts streaming, that is the time that it takes to sort of process and give the output. So it is faster as compared to Gemini 1.5 Flash. You have new modalities. So when I say modalities, modality, it is basically what kind of input or output does it expect or it generate. So it has new modalities like, it can generate image, it can also generate audio, and it can sort of take input as text, image, audio, or video, and we'll see that in the demo. What also is basically new in this is it has something called as native tool use. This is, there are multiple names to this. You can call it native tool use, you can call it composite function calling, but under the hood, basically what it is doing is it's able to call different functions. So what is function calling or tool calling? It's basically a way for the model to sort of fetch data or interact with external APIs. So if you have, let's say, a weather API and you want to get the latest data from, let's say, weather.com or any other APIs, you can sort of define or declare that particular API as a function and just mention it in the generation config of the model, and the model will start using that API to sort of get you the parameters that you can sort of use to call that API. It does not call the API directly. It basically just generates the parameters or the arguments that you need to send to a particular API based on the function declaration. And the last one, which is, I think this is the one that I'm most excited about, and as you would have seen the Project Astra demo, this is now something that we can build our own Project Astra. So this is Multimodal Live API. So what basically this does is you can sort of create real-time audio and video, streaming with the model, and you can build those applications. And how basically it works, I'll probably talk a bit about that in the subsequent slides. So moving on, this is just a recap of where we are so far from the models ecosystem that Google has from first party perspective. So we had Gemini 1.5 Flash. We still have this model. It's a faster model. It is cost efficient as compared to Gemini 1.5 Pro. You have Gemini 1.5 Pro then, which is basically it has better reasoning as compared to other models. And it has a 2 million context window. So basically you can upload, let's say, an hour's movie, a 44-minute or 1 hour movie, or you can upload, let's say, 1 lakh PDFs, and you can sort of ask the model to sort of go through the entire data and basically answer your questions or do any sort of summarization or any sort of logic. So this is Gemini 1.4 Pro. Then we had Gemma 2.2. This is the open weight model. This is like something that you can sort of fine tune and tweak. You can fine tune the other models as well, but this is like more open. So you get to see, what architecture this particular model is built into, and it has a lot of different model sizes, right from 2 billion to, let's say, 27 billion, and you have 7 billion and 9 billion as well. And there are a lot of variations in this. You have a code-specific model called Code Gemma. You have something called as Shield Gemma that basically helps you to filter out any unsafe prompts or unsafe text, etc. And then now what we have is Gemini 2.0 Flash. So yeah, I mean the entire performance and the cost is obviously, it's a never stopping process, and it will keep on evolving over a period of time. Talking about new capabilities in Gemini 2.0 Flash. So as I mentioned, it can take audio input as well as audio output. So it generates a very high quality audio output, so that you can have like a very interactive voice-based assistance, built using Gemini 2.0 Flash. And then also something that you have is basically it can generate an image, inline image. So probably if you would have seen the demos where you upload an image and you ask the model to sort of modify it or manipulate it, you can easily do that with just voice commands, and it will just do some manipulations on the image and regenerate the image. So it can generate images, inline images. Then Multimodal Live API, as I mentioned, it basically allows bidirectional, voice and video interactions, and you can basically create chatbots. You can integrate and sort of build like live translation applications. One thing that I will sort of mention here is it also has a feature on interruptions. So let's say if I speak and if I stop speaking, or I ask the model to sort of stop at a particular point in time while it is speaking or generating an output, it can do that very seamlessly. That has been built as a feature. Very underestimated, but it's definitely a feature that is useful. Then tool use, as I mentioned, function calling is there, but apart from that, what you also get is code execution. So it can execute code for you. So we have seen a lot of models by Google and other LLM providers as well, where it can generate code, but when it comes to execution of the code, it sort of falters, and you might not find that feature or capability. But here, it not only generates the code, but it will execute the code and give you the answer. And then also very important feature is search. So what we have launched as part of Gemini 2.0 Flash is you can use Google search as a tool. So let's say if you want to build an application where you want to ground your responses in Google search results, you can just integrate this Google search as a tool like any other tool using function calling. and it basically would use, and we will see an example of this as well, both on the UI as well as on the via code. And then lastly, what we've also done is there is a new SDK. It's a unified SDK, and we'll see the differences also in the slides, that allows you to sort of use a single SDK across both Google AI Studio and Vertex AI. So use the same model, and while you're prototyping, you're using Google AI. When you want to build a more production, more enterprise scale application, you can sort of move to Vertex with just a small code change in your existing code. So that's what the new SDK sort of helps you do that. Talking about Multimodal Live API, as I mentioned, it's definitely a feature that is gonna be used widely. And how does it work is basically using something called as WebSockets. So WebSockets it's not a very new concept. It's an old concept being used heavily in networking. So what it does, it basically creates a TCP kind of protocol with your model, and it creates a session that helps you sort of interact to and fro with the model. And till the time the server or the session is alive, you can sort of interact and do to and fro conversations with basically the model. Talking about, I mean, these are certain benchmarks. Yeah, I mean, obviously it's better, but I mean, I would leave this up to each and every developer, because no matter how good the benchmarks are, it should sort of help solve your problem that you're trying to solve, and basically able to integrate it with your application. So definitely does better in benchmarks as compared to the predecessors, and this is still the experimental model. So yeah, definitely we'll get new versions of this, and even the benchmarks will sort of improve. But there is more to Gemini 2.0. So it's not only the Multimodal Live API, which can hear and see you. You have Gemini 2.0 Flash thinking mode. This is a specific model, again an experimental model that has been launched. And what basically you do as part of this model is it basically generates intermediate thoughts and does advanced reasoning. So you can, as you can see the model card here, the input and output is basically 32K tokens, as compared to the other models like Gemini 2.0 Flash Experimental. It's 1 million token limit of input, and output I think is somewhere around 8K or something. And this particular model is definitely good if you are trying to solve a very complex task that requires reasoning, or you're trying to do some sort of code generation that in which you want the model to sort of think a little deeper and do a lot of intermediate steps execution while sort of generating the final response. So this is where this is useful. But one thing to note here is, obviously, as compared to the Flash 2.0 Flash Experimental or the 1.5 Flash, the latency would be higher here. Sorry, I will answer the questions in the end. But keep them posted in the chat. So I'll take them up in the end. So the latency here is something that would be higher as compared to the other models, because obviously there's a thinking process that is going on. But you might think about this, that we are obviously 2 years into the first model that was launched in the market, and we haven't seen a lot of prompting techniques like chain of thought, tree of thought, react, etc. Why is this better? Is because here all these things are being baked into the model while it is being sort of built. So that's why this is better. You don't have to define the rules. Obviously, you can mention them as part of the system instructions, but the basic level of thinking that a model does, or reasoning that a model does, that's already baked into the model while it was built. So that's why this is a better take at having a reasoning model as compared to having a generalized model and then putting a reasoning framework or a chain of thought framework on top of it. So that is on the thinking mode. Then yeah, so in terms of using these models, obviously nowadays, using language models, it's just importing an SDK and sort of creating a model instance, creating a client, and working with the types, and then get started. So it become as easy as that, as compared to few years back where you had to import a lot of models. So that's where the new Gemini or the Gen AI SDK that Google has launched is much better. So on the left-hand side, as you can see, the earlier package was Google-Generative AI. So now everything has been streamlined. Now you have one SDK called Google-Gen AI. And then you create a client. And then once you create a client, if you're using it in, let's say, Google AI Studio, you provide your API key. But if you want to use the same code in, let's say, Vertex AI or Google Cloud Platform, all you have to do is basically just replace this line and just enable Vertex AI and give your project details, which location and what is your project ID. So this porting becomes relatively easy because Google AI Studio is good for, let's say, prototyping. But if you want to build something, let's say, for enterprises and customers, because I work with customers mostly, so that is where Vertex AI is something that it's preferred both from a security and privacy perspective. And if we talk about, let's say, some differences in terms of the Vertex AI SDK to Google Gen AI SDK, this is the comparison. I'm not sure if a lot of you have used Vertex AI or you played around with Vertex AI SDK. So Vertex AI is a managed AI platform by Google Cloud, and basically it gives you everything from large language models to all the other models. There's something called as Model Garden in Vertex AI that not only has Google's first-party models like Gemini, it also has certain open source models like Llama and DeepSeek, etc., as well as certain other models with which Google has a partnership. Like you have Anthropic Claude hosted as part of the Model Garden. So basically, you can use any model from the Model Garden, be it Google's model or any third-party or open source models, and then build the entire workflow in Vertex AI. And then you can sort of add different layers on top of it, like you want to put observability, you want to put evaluation services, you want to do orchestration of the entire pipeline, you want to do fine tuning, etc. Everything can be streamlined and implemented as part of Vertex AI. So that is basically the power of Vertex AI. So let me quickly jump on to the demo. So this is Google AI Studio. So this is where you access all AI models. So here, let me zoom this up. Okay. So here, what you see is basically this is the playground. On the left-hand side, you have different capabilities that you can sort of play around. On the right-hand side, you have the standard parameters and the model selection that you have. So you can see a model card in terms of what is the token limit and all. And you get a lot of other features like, you can enable grounding, which is basically it will go for Google search and see and find references to its answers. Or if you want to edit safety settings, you can basically do that as well here. So here, this playground, I think most of you have already seen. You can just type in a prompt, and basically you can run the model and it will sort of respond. So this is basically a basic playground. You can try out different models, whichever one works for you. You have the thinking experimental as well. So yeah, so this is something, and you can add a system instruction here, and you can basically provide some sort of context to the model before it starts generating an answer. Now the second one before this, I think if you want to, so I'll get to the code part a little later, but let me just demo this. So now what you have here is also something called a stream real time. This is nothing but the multimodal live API that I've been talking about. So what you can do here basically is, obviously the model that it supports right now, it's Flash experimental. You can choose the audio for output format. It could be audio, it could be text. You can choose a voice, and then basically you can choose some of the tools that you can basically help the model sort of augment and sort of interact. So let me start off by starting the recording. How many fingers am I holding? What am I holding right now? Which was the last Deadpool movie? Yeah, so as you can see, it was not able to answer that question. So now let me try something else again. So this time I am starting again a live session, but this time I am enabling grounding. So let me do that. What logo is this? Which was the last Deadpool movie? Can you use Google search? Who played Wolverine in the movie? Who played Wolverine in that movie? So as you can see, it can sort of interact with the surrounding with the video. And something else that I can do is, let's say there is also something called as code execution, as I mentioned. So it basically not only generates code, but it will execute the code. Let me demonstrate this. So let's say this time, let me share my screen. Uh, uh, can you see my screen? What document is there on my screen? Can you tell me how much did cash and cash equivalents reduce from 2023 to 2024? Can you use code execution to calculate the percentage decrease? Can you use code execution? Yeah. So as you can see, I was sharing my screen. It was recording everything that I was showing on my screen, and it tried to calculate that value, but I didn't want to let it calculate it because I don't, let's say, rely on it. I wanted to basically execute a code. So it basically extracted the values, created a small Python code, and then it basically did the calculation. So now, at least now, I'm sure that because this code seems correct to me and the execution is correct to me, now I can rely on it that, yeah, it decreased by 17%. So this is how you can basically use the real-time, like the multimodal live API either to sort of interact with the video that you want to share, or you want to share your screen while you're doing something and basically do certain calculations, find certain inferences, or just talk to the model and understand what sort of thoughts the model has that can be sort of help you solve any sort of problem. So while you're even coding, you can sort of have this model look at the code, understand what you're trying to write, and if you're stuck somewhere, it can sort of help you there as well. So that's the power of this new model, and definitely something that I am most excited about. So I will just quickly move on to the code. So this is something that you can find in in the cookbook. So what you have to do is basically go to this repo called Google-Gemini, and you will find a pinned repo here called Cookbook. Now this has code examples from the previous model as well as the previous SDK. So all you have to do is basically go to Gemini 2.0 or to folder, and you will see all the notebooks. So I'm sort of using the get started notebook. So here, the first thing is basically I'll connect to the Colab runtime, and while this is creating a runtime for me, I will the first thing that I need to do is basically have a Google API key. For those who don't know how to create one, you go to Google AI Studio, you sign in with your Gmail account. It's free of cost, and then you go to this particular option to get an API key. I won't click on it because otherwise it will sort of expose my API key. So once you get that API key, all you have to do is basically come back to your notebook, and you just define a variable here and just add the value. So you store that secret as part of your Colab notebook, and you just enable the notebook access to that particular secret, and you're good to go. So I can basically now, the first thing I'll do is basically install the new SDK. As I mentioned, it's a new SDK, Google-Gen AI. Then I basically sort of get my Google API key from the secrets that I just stored here. Then I sort of initialize the client from which I will sort of use all the models. So now I'm using Gemini 2.0 Flash. So I just define that. And then, you're good to go. You can start prompting. Let me just zoom in a bit. Yeah. So this is just a simple prompt right now. It will sort of generate, let's say, the answer. The answer is already marked down. So the output that the model produces is always marked down. Something that you can do also, and it's important at times when you want to manage your cost as well as how much tokens you want to sort of send and receive. It also sort of affects the latency of the model. If you're sending too many tokens, at times you might sort of get a delayed response. So as part of the SDK, you can easily count tokens. So it basically, like if I run this, it sort of talks about the total tokens that are there as part of the question that I'm asking. It's 10. Cache tokens is none. Caching I'll talk about later. But you can keep certain data or certain context as cache as part of the model's cache. So what it will do is basically you don't have to send the cache again and again to the model. So you will save up on tokens as well as on cost. Then talking about multimodality. So as I mentioned, it can easily sort of take image as an. So here I am sort of just downloading an input. So PIL is a package by very famous Python package called Python Imaging Library. It basically used to sort of take an image as an input and sort of store it in the code. So what I'm doing basically is just passing the image as part of the model. So in this case, I have the prompt as well as the image. And then what I'm asking is to basically write a short and engaging blog post based on the picture. So the picture that I have is basically of a jetpack. Yeah. So this is the picture that I had uploaded. So it sort of wrote a short blog post. Is this the future of commuting, etc. So this is how you can sort of send an image as well as a text and get some output. In terms of configurations, now here you must have seen a couple of these already. So temperature, the most common ones if you want to sort of tweak the creativity of the model. Temperature is basically how randomly the model would sort of select a particular token from a list of tokens that it's supposed to sort of send out. Top case, obviously, it sort of creates a threshold in terms of how much token do you want to send based on, the number of tokens. Let's say the top 20 tokens you want to send out of, let's say, the 100 tokens that are there generated by the model. Or you want to create a threshold in terms of the probability of each of those tokens. And let's say if you want to send only those tokens that, in totality is just 95% of the probability. So you can send those tokens and sort of, ignore the rest, which are not very much useful. Then you have candidate count, which is basically how many, parts do you want. You can increase the candidate count to generate multiple responses. Seed is just to make sure, you want to recreate the same sort of responses from an experimentation perspective. Maxed output tokens, this is basically how many tokens do you want model to generate, and it will sort of stop there. So if in this case I have specified it as 100, so if you see the output, it sort of stops abruptly because this is where 100 tokens sort of ended. Yeah, these two are something new, relatively new, not used right now, so I won't talk about those. Stop sequence is basically, this is where basically the model understands in the entire token generation in the backend. Wherever that stop sequence comes, it will sort of end the generation there. So this is what basically you can use for. And then in terms of safety filters, as I mentioned, there are 4 or 5 safety filters in terms of harassment, hate speech, sexually explicit content or dangerous content. And I think there's one more. So you can basically modify the responses. So basically the way the model generates the output, it does not completely block everything. It would sort of flag the response if it falls under one of those categories. And there is basically some sort of algorithm that has been built in the backend that basically classifies a particular response into one of those categories. So you can basically look at the output and understand if it is falling under one of the categories, then you can sort of filter it out further, and so that your user does not see any unsafe responses from the model. So yeah, this is just an example of that. So we were looking at simple generation. So that's where you use something called as client.models and generate content. This is just simple generation. But if you're trying to build a chatbot and you want a multi-turn chatbot, you have to use something called as clients.chats, and you create a chat session, and then basically you can start interacting with the model. So what the model does is basically it keeps the context of the previous questions as chat history. And let's say here I'm asking it to sort of generate a function that checks if a year is a leap year or not. And then the follow-up question is, write a test case for the generated question. So the generated function. So basically, it uses that, it already has that as part of the history, chat history. So it sort of created a test case. It gave a test output also. So that's how you can sort of create a chat session and then start interacting. Control generation. This is very important, and I would say this is something that probably the most used feature that probably at least I have used a lot of times, because a lot of times I have to sort of ingest a lot of data, send it to the model and extract the data from and extract specific entities from the response or from the data that I'm sending. And oftentimes I wanted to basically generate that output in a very formatted JSON, so that I can sort of ingest it further in my downstream applications. So this is where control generation sort of helps out, and it basically uses something called as Pydantic. If you worked with Python, Pydantic is a very famous schematic library built in Python. So what you basically do is basically you define a class mentioning all the necessary components or the variables that you want from the output, and you just pass it as like to the model in the config. And then this is important, you have to mention the MIME type as application/JSON, so that the model understands that it has to generate JSON. So here I asked like provide a cookie recipe and its ingredients, and I gave a schema. So it gave the recipe description, it gave the recipe ingredients, and you can see it's a nice nested JSON that has like different keys and multiple lists, etc. Within it. So yeah, now this becomes easier for me to sort of use it further, extract certain key value pairs from this, and then process it further. So very important feature, probably, and this is a better way of sort of extracting structured data as compared to prompting the model to generate it in a proper structured JSON. That might work, let's say 100 times, but maybe the 101st time it might fail and it might not give you a structured JSON. It might give you quotes JSON and then the form, then the output. So yeah, so this is very, very important. Generating content stream. So this is again, if you want to stream the responses and you don't want to sort of generate the output. So you can see the streaming also is something that is an important feature. It's a very important UX element right now in most chatbots, because you don't want the user to feel like nothing is happening or something is wrong with the model and my response is not being generated. So yeah, you can do like an asynchronous request also. So you don't want to all the responses chunk by chunk, and you want the entire response to be generated and shown to the user at one go. So it will do an asynchronous request via the client, and you get the entire output together once the model fully processes the response, the prompt, and it will generate the entire response in one go. In terms of function calling, as I mentioned, so this is again the second most used feature. So what you have is basically you can have a function or an API, and you just give a declaration of that API in terms of what kind of properties does the API or the function have, what kind of input does it accept, and give a proper description. This is very important. If the description is very bad, your model will not call the right function if you have multiple functions. So here in this case, you want to get some destination. So my prompt is like, I would like to travel to Paris. So now you can see the output is function call. It definitely shows you that. And then it shows you the argument. So what you can do is basically use these arguments and then pass it to an API. So let's say if you're working, let's say with REST APIs, and you want to pass these arguments as parameters as part of the request payload, you can easily do this because the model is now basically extracting this from the user's prompt. So yeah. So in terms of uploading files, I think this I already showcased. You can upload an image, you can upload a text file, you can upload a PDF. Other file formats right now are not supported, like docx and PPT, Excel, etc. You can upload an audio. So this is something different. So now I have like a State of the Union audio. Sorry. This is an audio MP3 file. I can upload it to the model and ask the model to provide a brief summary. So yeah, then you can also upload a video. Just one thing. So yeah, it provided a nice summary of the entire audio, and it also gives some context about what it got from the audio, which probably would have not provided in the prompt. So yeah, then you can upload a video. So this is something that I'm downloading from the internet, and then basically I can upload the video. So basically here, the important thing to understand is you have to upload it as part of client.files. So once you upload it, the second step is basically you have to process the file, process the video basically. So you have to let it process, because unless and until it is processed, it will not be sort of used by the model. So you can check the state of the video file. It's been processed, it's active. Now I can sort of send this file to the model. So I'm just asking it to describe what is there in a particular video. Yeah, so obviously video will sort of take more time to sort of process, and then the model will sort of respond accordingly. Yeah. Meanwhile, I think this is being processed. I'll quickly talk about context caching. So as I mentioned, you can have certain context already cached as part of the model. So yeah, so I think the output is here. It sort of talks about the opening scene, the plot, end credits, music and sound, etc. So yeah. Context cache is something right now available only with stable versions. So the experimental model, you won't be able to use the cache. You'll have to build your own cache. But if you want to use the older models, you can use, just provide some system instructions, some URLs that you want to cache, and you can just upload it as part of the model cache. Once this cache is created, any question that you ask to the model, the tokens that will be utilized will be the prompt that you send, and not the cache. The cache tokens are maintained as is. So basically, you're not sending, let's say, 1,000 tokens. You're just sending, let's say, 10 or 20 tokens at a time. But it's using those 1,000 tokens as a context. One thing to note here is you can also define how much time do you want the cache to be alive based on your application, your system. And then you can delete the cache as well. Gemini, I mean, this is, I think, the embedding model, again, nothing related to Gemini 2.0 Flash. This embedding model we've already there. You can create numerical representations of the text. And then mostly this is used in RAG kind of application where you want to sort of have a vector database where you have indexed and stored the embeddings of your text from which you want to retrieve answers, and then use this model to sort of do some sort of semantic search on top of it. The last bit on this is the search as a tool. As I mentioned, now Google search is something that you get as a tool. So the way to call is basically you create a Google search tool, you import Google search, and then basically pass this particular tool the way you would have seen in the previous example that I was doing with function calling as well. And then basically once you send it and give Google search as a tool, what it will do is basically give you the answer. So here, the answer, it sort of used Google search to give the answer. And then also as part of the answer, you would see the links. So this is the link that it used to sort of the Google search result that it used. So you get these references, so you get more factuality in your answers, and you can build the grounding accordingly. So yeah, so I think that is it what I wanted to cover in a short period of time. If there are any questions, I can quickly go to questions. Sir, which is better, GPT or Gemini? I can't answer that, sorry. Uh, is image recognition at text level? Yes, it is. It supports image recognition. Uh, so you can get bounding boxes also, not just text. But let's say if you have multiple objects, it will sort of understand and create bounding boxes and understand, what element is there and accordingly try to respond. Let's say I'm sitting here and behind me there is a clock, so it will sort of identify that as well. Can AI models be frustrated too? I don't know. It depends on how much we try to get out of them. I think those, and any other questions on the chat? Sure. Sorry, injury detection prevention. Yeah, you can use the live API. Probably you'll have to sort of test and see. Google already has a Vision API that you can use, and that has certain features that can help you sort of detect those. But if you have a use case, very specific use case where you want the model to also interact, then you can use Gemini 2.0 Flash to sort of detect injury, and as well as sort of respond on time. So you don't have to build anything custom using different components. You can sort of use the model altogether. I frankly don't have an answer. Probably will have to test it. There was a model or an experiment that was conducted with the previous generation, which was Gemini 1.5 Pro. So there was something called as Mode Gemini that was created. So Gemini 1.5 Pro does accept images. So somebody had created an experiment wherein they had fine-tuned the model to sort of understand MRI images or any sort of CT scans, etc., to sort of derive certain inferences. So that it was called Mode Gemini. So yeah, if that is possible, definitely, with Gemini 2.0 Flash also. Yeah, so the best place to start off is this cookbook. This has tons and tons of recipes. I hope my screen is still visible. So for the multimodal live API, which I think most of you would be more focusing on. So there is a live API starter. This is just a sample code that can help you. Yeah, I can share the link. Yeah, this is the link. So here you have the live API starter notebook, which you can just run and you can start interacting it with your laptops. One thing to note here is if you use, you will have to use headphones because noise cancellation is something that is still that is not part of the model. That is something that you have to figure out. So with headphones, you will be able to talk to the model better, and it will start responding to you. So this is a good way to start off. And then there is also a specific folder on WebSockets, how you can use it specifically with the Gemini 2.0 multimodal live API. And then yeah, rest of the recipes, I think there are a lot. Like special understanding. There is one on thinking also, the thinking mode model. If you have a use case for that, you can definitely go for this. So this has a lot of examples like solving complex geometry problems, or brain teasers, etc., or coding. I think there's one on coding as well here. Yeah. So yeah, this cookbook is the way to start. So right now 2.0 doesn't have any sort of tuning capability yet launched, but you can use, I think you have 1.5 Flash. I'll have to check if right now this is only text-based tuning. I don't think so. Image-based tuning or video-based tuning is right now enabled here. So, but yeah, you can use probably Polygemma. So Polygemma is another model, part of the Gemma open weight model ecosystem, which is a open vision model that you can easily fine tune. It is a vision image-based model. So video right now, I'm not sure if it is supported. Image based, I think you can use 1.5 Flash. I think in Vertex AI you have Gemini 1.5 Pro also for image based tuning. You'll have just have to create the data set. I think there is a good amount of documentation available on the official this thing. From Google AI Studio, I don't think so image based tuning is right now enabled. In terms of which model is better, I think it totally depends on the use case. Mostly, I am understanding it is more of an OCR kind of use case. So I think any of the models like 1.5 Flash or 1.5 Pro should work out. But Gemini 2.0 Flash, right now, no tuning available. It is only available for the Multimodal Live API and experimenting. Sure. Thanks a lot, Uzma, for inviting me. And anyone else, feel free to reach out to me on LinkedIn if you have very specific questions on Gemini, and if you want something like some sort of feedback, happy to help. Sure. All right. All the best for the solutions challenge. I hope a lot of amazing solutions will come out, and would love to see some of the All right. Thanks, everyone. Bye.